The terms casket and coffin are often used interchangeably, but their use as synonyms is no open and shut case. Coffins are actually those 8-sided burial boxes that are narrower at the bottom. Think Dracula. Whereas caskets are rectangular. They can be made of metal, plastic, or wood. Whether the wood is ash, oak, mahogany, or something else, the casket's construction is generally the same. First, they run wood slats through a machine called a molder. This profiles the edges, carving a tongue on one side of each slat and a groove on the other. A worker applies glue to these edges, then positions the slats in a rounded vise that locks the tongues and grooves together. The glue dries in an hour and a half, bonding the slats permanently into a large curved piece. This piece will form the top and long sides of the casket's rectangular cover. To complete the rectangle, a worker now makes a V-shaped cut on each side and glues in a triangular piece of slatted wood. While a press clamps the components tightly together, he secures the end pieces in place with joint fasteners, which are like heavy-duty staples. Now a machine carves a groove into the cover's underside at the midpoint. A worker glues in a wooden piece, securing it with joint fasteners. This piece is called the bridge, and it's the point at which the cover will be cut in half later on. They transfer the casket cover to an automated machine that gives it a rough sanding, then a finer sanding. The next step is to attach a decorative molding to the base of the casket cover. This molding has a groove on the inside into which they'll later tuck the edge of the casket's upholstery fabric. A worker glues a small piece of wood in the groove at the midpoint so the groove won't show when the cover is open. Now he saws the casket cover in two, right through the bridge. Meanwhile, another worker assembles the bottom of the casket called the box. He glues together the sides and applies a bottom molding, securing everything with joint fasteners. At this point, the box is upside down. He attaches the bottom, then flips the box right side up. Now it's time to join the cover and box using 4 hinges. They spray the casket with one of countless shades of wood stain, then rub it in equally over the entire surface. The casket goes into an oven for an hour to dry the stain. Next, a worker sprays on 2 coats of lacquer with 40 minutes drying time between applications. This happens to be a high-gloss finish, but many models have a duller sheen. Once the lacquer dries, a worker attaches handles. The more expensive the casket, the fancier the features. This higher-end oak model with decorative corners has wood and metal swing handles. Other models have all-metal swing handles or fixed bars made of wood, metal, or both. The fancier caskets also have an adjustable wooden bed inside with a mechanism to adjust the height. A worker covers the bed in fabric. The base model bed is made of absorbent paper laid over a product called wood wool, which is simply shredded wood. The upholsterer lines the inside of the casket with foam, covering it with either velvet, satin, or silk polyester crepe. By folding, nailing, and stapling this fabric a certain way, she creates pleats, tufting, and other design details. Generally, the more expensive the casket, the finer the fabric, and the more ornate the upholstery. A decorative trim hides the staples. Fabric straps or metal elbow brackets hold the cover open. When it comes to how beautiful and elaborate caskets can be, the ground's the limit. The bagpipe is one of the oldest instruments. To play it, you blow into a pipe attached to a leather or synthetic bag, then press on the bag to force the air out through other pipes to create sound. You transform this sound into a melody using finger holes on a reeded pipe called a chanter. They start by carving a 20-centimeter long block of wood, rounding it to a diameter of 4.5 centimeters. It's part of a drone, one of 3 on the bagpipe, that create bass and tenor harmonies. They drill a hole that will later become an air channel. Using a lathe and a plastic template as a guide, a craftsman spins the wood to carve it, a process called turning. The lathe has a stationary carbide-tipped cutter, strong and precise enough to cut this hard African blackwood. It's a very heavy and dry wood, perfect for turning. For more intricate decorative cuts, he uses a handheld device called a combing tool. Next, he uses what's called a parting-off tool to make additional decorative grooves. He measures these grooves using a caliper to ensure they meet the specifications of the design. The craftsman drills a hole to create what's called a projecting mount. It's made of imitation ivory, and at 5 centimeters in diameter, it fits on the drone like a washer. But it's just for decoration, one of 7 on the bagpipe. He adds a metal component called a slide, also for decoration. Next, he turns what's called a blowpipe. This one's made of plastic to withstand moisture from saliva. Traditionalists prefer blowpipes made of wood. He adds a mouthpiece. It retracts by 20 centimeters depending on the player's height. The player blows into the mouthpiece to inflate the bag. A small metal tube between 2 plastic blades forms the chanter reed. When air strikes it, the reed vibrates inside the chanter, a pipe at the bottom of the instrument that has 8 finger holes for notes and 2 for pitch adjustment. To secure it, the craftsman wraps the reed with hemp string and winds Teflon tape over the string for an airtight seal. Then a brass wire called a bridle to control the shape of the reed. Narrowing the opening produces a higher-pitched sound. The craftsman ties hemp string to create traction between the drone segments, holding them together. Hemp string is especially durable, yet easily replaced if damaged. Here's the completed tenor drone. Next, a craftsman inserts what's called a stalk through the zippered opening of the pipe bag. The pipe bag's made of synthetic, breathable material. The 5 stalks fit through a rubber collar in the bag, attaching to the 3 drones, the chanter, and the blowpipe. The craftsman inserts the chanter through a sleeve in the bottom of the pipe bag. He secures it with string, tightening it around the bag. He closes the zipper to form an airtight seal. Next, he places the pipe bag into a decorative velveteen bag cover. He inserts the stalks through holes trimmed with wool or silk fringe. A rubber valve prevents the player's air from coming back up through the blowpipe, channeling it through the chanter instead. Another part, called a drone reed, acts like a plastic tongue. It vibrates over a long hole to create the bagpipe's humming sound. The craftsman inserts the drone reed into the drone and then into its stalk. Wool cords keep the drones in place while the player plays. Finally, the craftsman fits the chanter reed into the chanter, then slides it into its stalk. A bagpiper must have a strong set of lungs because some songs can run for 20 minutes. Now that's long-winded.
Garage doors come in many styles, colors, and materials these days. They can be made of steel, aluminum, wood, or vinyl. Whether you choose a style that's plain or paneled, smooth or textured, a sign of quality is that the garage door is lightweight, well insulated, and airtight. The typical residential garage door is made up of 4 panels. Each one begins as a sheet of either aluminum or steel, 2 metals that can tolerate harsh climates. The side that will show has a baked-on coat of polyester paint. Depending on the model, the sheet passes through rollers that imprint a texture, such as a simulated wood grain. Then it goes through a press that imprints a design. This model will have raised rectangles. Others have horizontal stripes or no design at all. After an automated machine cuts the continuous sheet to garage door widths, another machine folds over the edges. This creates 1.5 centimeter joints for attaching the panels. The polyester paint is elastic, so it simply stretches with the bending. Now on the back side of the sheets, they hot glue metal plates to reinforce the various components they'll later screw into the garage door. Parts such as the lift handles, the hinges, and the bracket for the electric opener mechanism. They also drill a hole through which they'll later inject insulation. Now they slide 2 sheets together to form a panel. They close off the ends with blocks of pine. This will prevent cold air from penetrating inside. They apply various stickers with installation, maintenance, and safety information. Then orange stick-on dots to mark the location of the metal plates into which the installer will screw the hinges and lift handles. Now they attach an aluminum bar to the long ends of each panel. This holds the panel steady during the injection process. After injection, the bars come off. They load the panels onto a carousel and begin the process of filling the hollow interior cavity with insulation. Through the hole they drilled earlier, they inject polyurethane foam, an expanding plastic insulation material that's specially designed to penetrate hard-to-access spaces. As we see in this demonstration, the polyurethane expands and becomes rigid. This creates a solid core inside the garage door. Polyurethane is one of the lightest types of insulation, so it doesn't make the garage door heavy. Here's what the inside of a panel looks like once the foam hardens. Now, workers install various components, such as the rubber weather seal on the bottom panel. This seal prevents cold and water from entering the garage under the door. Some garage door models have windows to allow in natural light. Workers first use a high-speed router to remove the rectangles where these windows will be installed. Then they insert one of several window styles available. These are double-sealed windows, 2 thermal panes with an aluminum spacer in between. The framing around the glass is available in different colors. It's made of PVC, a synthetic resin that doesn't discolor. The frame prevents water and cold air from penetrating. Workers pack the installation hardware. Then they weigh the box to ensure no part was left out. At installation time, they attach the door panels at the joints with hinges. A system of springs ensures the garage door is perfectly balanced and moves smoothly. If properly installed, you should be able to lift or lower the garage door using just 2 fingers.
We take well-lit streets for granted, but there was a time when venturing out at night meant traveling in complete darkness. In 1814, the first gas lights lit up the streets of London, England. The first electric streetlights illuminated a public square in Cleveland, in the United States, in 1879. These streetlight poles are made of what's called composite, a combination of fiberglass and epoxy resin. Epoxy resin is a gooey liquid plastic mixed with a hardener. The factory constructs each pole on a mandrel, a long tapered metal cylinder. Workers first lubricate the surface. Then they take what's called fiberglass filament, a string composed of 2,200 tiny fiberglass strands. They'll wind dozens of filaments around the mandrel to create the pole. But first, the filaments go through a bath of epoxy resin. This resin is moldable, and once it's heat-cured, maintains its shape. Once the filaments come out of the bath, a machine called a filament winder wraps them around the rotating mandrel. The speed of rotation in relation to the speed of the winder is critical because it dictates the angle of the fibers. The lower the angle, the more that part of the pole will be able to withstand the wind and provide constant, stable lighting. When a pole bends in the wind, the light appears to flicker. The number of filament layers depends on the design of each specific pole, and that's determined by a couple of factors. First, the type of light fixture the pole will hold. The bigger the fixture, the stiffer the pole has to be. The other factor is wind. The windier the location, the stronger the pole has to be. Once the winding's done, the mandrel moves on to the curing station. They pump pressurized steam into the hollow inside of the mandrel. The heat kickstarts the hardener in the epoxy resin. This solidifies the resin and cures it. The mandrel rotates so that the pole cures evenly. Curing time depends on the length of the pole and how many filaments it's made of. To help extract the pole, they pump cold water through the mandrel. This makes the steel mandrel contract, loosening the pole. Remember how workers lubricated the surface of the mandrel before winding the filaments? Because of that, the pole just slides off. The pole now moves on to the finishing stages. First, an automated sander works the surface. The customer can order from a choice of surface textures, from smooth to rough. Sanding takes just a few minutes. Now a saw makes a neat cut at the top of the pole where the metal tenon will go. A tenon is the component that'll hold the light fixture to the pole. This particular model has an arched mounting arm. The composite has cooled a bit since curing, so they reheat it to make it flexible. After a bending machine makes the curve, they spray cold water inside to cool the material. This registers the curve in the resin's memory, setting the bent shape. Now they cut out the hand hole, the opening through which the electrician will connect the underground wire to the fixture wiring. Workers then spray the pole with urethane paint. The paint acts like sunscreen, protecting the composite from damaging ultraviolet rays. This grommet hole will connect to the underground pipe that contains the electrical wires. After installing a cover over the hand hole, it's time to assemble the parts. The underground pipe to the pole, and the pole to the tenon and light fixture.